Every summer, millions of homeowners make the same expensive mistake. The upstairs gets hot, the air conditioner runs for hours, and instead of asking why the house is trapping heat in the first place, they simply lower the thermostat and pay the bill. But before air conditioning became normal, homes still had to survive summer. Farmhouses had bedrooms. Families cooked indoors, children slept upstairs, and people had to get through August heat without a machine running all day in the background. The Amish never forgot this because they never built their homes around the assumption that a compressor would fix every bad design decision. They used air flow, shade, attic ventilation, night cooling, and simple materials that worked with the house instead of fighting against it. And the idea behind all of it was simple. If you move heat out before it gets trapped, you do not have to pay as much to remove it later. Number 1. The attic chimney effect. The hottest place in your home during summer is probably not the living room or the bedroom. It is the attic. On a hot afternoon, that space above your ceiling can reach 130, 140, sometimes even 150 degrees Fahrenheit. Once that heat builds up, your ceiling becomes the floor of an oven. That heat pushes downward for hours, even after the sun goes down, which is why upstairs bedrooms often feel hottest at night. Older Amish farmhouses were designed to avoid this by giving hot air a clear escape path at the highest point of the structure. That is where the cupola comes in. Today, people often see a cupola as decoration, but originally it was practical. It was a chimney for hot air. As the attic warmed, the hottest air rose toward the roof peak. The cupola gave that air a place to escape through louvered openings, while cooler air was pulled in below through shaded windows, doors, soffits, and lower vents. Modern engineers call this stack effect. The Amish simply built around it because they had to. The lesson is simple. Cooling is not only about creating cold air, it is about removing hot air. Your home may not need a full cupola, but the principle still matters. Your attic needs a high exit, whether that is a ridge vent, gable vent, turbine vent, or properly designed roof vent. If hot air has no way out, your air conditioner is not cooling a house. It is fighting a furnace above your head. Number 2. The whirlybird roof vent. You have probably seen one before. A small spinning metal dome on a roof, turning in the wind. Most people ignore it, but that simple vent may be one of the cheapest ways to pull heat out of an attic without electricity. It is called a turbine ventilator, or whirlybird. Old barns, workshops, warehouses, and farm buildings use them everywhere because they solved a real problem. Hot air rises into the roof space, and the whirlybird gives it a moving exit. When wind passes over the turbine, the head spins, helping pull warm attic air up and out. At the same time, cooler outside air is drawn in from lower vents. No motor, no compressor, no smart controller, just wind, rising heat, and a metal vent doing its job. But whirlybirds disappeared from many modern homes for reasons that had little to do with physics. Cheap versions became noisy. Some were installed badly. Some homes had blocked soffits, so the turbine had no fresh air to pull from below. And in newer neighborhoods, clean roof lines became more important than function. But outdated does not mean useless. A properly installed turbine vent can still reduce trapped attic heat and help your air conditioner work less. The key is that it must be part of a complete airflow path. If the soffits are blocked, insulation is stuffed against the eaves, or the attic has no low intake, the whirlybird can spin all day and still do very little. The vent on the roof is only half the system. The air coming in from below is the other half. Number 3. The gable vent reset. This is the cooling trick many homeowners already have, but do not realize they have. Older homes often have gable vents near the attic peak, usually on the short ends of the house. From outside, they look like small louvered openings. From inside, if they are working properly, you should be able to see daylight through them. But in many homes, those vents are not working at all. They are painted shut, covered with dust, blocked by insulation, stuffed with debris, hidden behind bird nests, or sealed by a previous owner who was told that all air movement was bad, and that one mistake can change the temperature of the whole house. When gable vents are clear, they allow hot attic air to move out and replacement air to move in. If there are vents on opposite sides, they can help create crossflow through the attic, but when they are blocked, the attic becomes a dead air chamber. The roof cooks from above, the attic stores the heat, and the rooms below pay the price. This is one of the easiest fixes because it does not require a new system. It often means restoring a system that was already built into the house. Go up on a cool morning, never during peak afternoon heat, and look. Can you see light through the vents? Can air pass through the screens? Is insulation blocking the airflow path? If the answer is yes, your home may already have a passive cooling system that has been muted for years. Sometimes the answer is not to add more technology. Sometimes it is to remove the blockage. Number 4. The shaded night flush. This one is so simple that most people underestimate it. During the day, your house absorbs heat. The roof absorbs it, the walls absorb it, the attic absorbs it, the floors, furniture, and framing absorb it. Then at night, many people keep the house sealed, leaving that stored heat trapped inside. Older homes followed a different rhythm. During the day, keep heat out. At night, release the heat that got in. After sunset, when the outside air drops below the indoor temperature, lower shaded windows are opened slightly. Higher vents or upstairs windows allow warm air to escape. The house uses the cool night air to flush out the heat stored during the day. By morning, the structure starts cooler, and if the house starts cooler, it takes longer for the next day's heat to become unbearable. This does not mean opening every window at noon in a heat wave. That usually makes things worse. Timing matters. Cool air enters low, warm air leaves high. That is the same principle behind cupolas, gable vents, and roof vents. Modern air conditioning made people forget this rhythm. We started treating the house like a sealed container and the machine like the only solution, but the old method reduced the load before the machine was ever needed. And when you reduce the load, everything gets easier. The house feels better, the AC runs less, the bill drops. Number 5. The breathable heat filter. This is the cheapest method on the list and probably the strangest to modern ears. In some older farmhouses and attic spaces, plain breathable fabric was used near hot vents or sun-exposed openings to soften direct radiant heat and dust without stopping airflow. Cotton muslin was common because it was cheap, breathable, easy to replace, and widely available. The goal was not to block the vent. That would destroy the system. The goal was to filter and soften the incoming air while still allowing movement. Think of it like shade cloth for airflow. If a vent faces harsh afternoon sun, direct radiant heat can pour through the opening and heat the attic materials nearby. A loose, breathable layer of white cotton or similar fabric can reduce some of that harshness while still letting air pass. This is not air conditioning. It will not turn a hot attic into a refrigerator, but it can reduce dust, soften radiant heat, and improve the comfort of air moving through a passive ventilation path. The warning is important. Never pack fabric tightly against vents. Never place it near electrical fixtures, hot equipment, chimney areas, or anything that could become a fire risk. And never use it in a way that blocks airflow. The fabric only helps when air can still move freely. That is the key principle in every old cooling method. Do not block the air, guide it. A cupola needs lower intake. A whirlybird needs clear soffits. A gable vent needs an open path. Night flushing needs the right timing. A breathable heat filter needs airflow. The old systems worked because they were systems. Modern homes often fail because we break those systems into pieces, forget what each part was supposed to do, and then pay a machine to cover the mistake. The Amish did not preserve these methods because they were trying to be old-fashioned. They preserved them because they worked. Because heat that escapes for free does not have to be removed by electricity, because shade, airflow, and ventilation do not send a monthly bill, and because the best cooling system is often the one that prevents heat from building up in the first place. So before you assume your air conditioner is too small, look above your ceiling, check the attic, check the vents, look for blocked airflow, look for trapped heat, look for the places where your house stopped breathing, because your home may not need more power, it may need a path. Hot air still rises, wind still moves, shade still works, night air still cools. And if your house feels impossible to cool this summer, the answer may not be hidden in a new air conditioner. It may be hidden in a vent that was painted shut, a roof space that stopped breathing, or a simple old method that disappeared when cooling became something we were taught to buy instead of something a house was built to do.